Hi there. Let's get going. Any updates, Steve or Mike?
I appear to be just gradually falling down the leaderboard. I just getting worse. It appears to be, yeah, like at the start of the week, I think it was about 30th, and now I'm about 50th. So,
Uh,
yeah, like it seemed to
yeah,
be like
no.
a lot of people just suddenly developed good kernels. So,
Uh, and yeah, it seems like a lot many more people are joining in because I think the competition is long enough that some people just deferred. Oh, we'll just join in the last month or something because there's like about, I don't know, maybe 15, 20 days left, I think.
yeah,
So I suddenly see a spike in the total number of participants. Yeah, I've been um, falling down significantly as well. Um, and I did have a couple of questions for both of you because I'm seeing something, thanks to your suggestion, Steve, I did adopt the, run in the environment that the original notebook is in method that you had pointed at how to ensemble.
yeah,
And that worked for me. And in fact, it seemed to indicate, which might have been the problem in the original thing, that somehow one of the things I was ensembling was needing to have the internet turned on or something, which I haven't debugged. Um, but the others, if I can share my screen for a minute, let me know whether you see my screen.
yeah, I see that now, yeah.
Yeah, and so what I did then was using that method, I first created a notebook which just combines, the Debata family and then the SVR,
Yeah,
just the two of those, and ran it, and it ran to completion. And then I submitted it, and I see a notebook timeout. And I was wondering, I thought both you and Mayank were able to run just those two combinations to completion. Is that right? Or do I have that wrong? Or
I've never run them to completion. And I initially did before, yeah, so you're running the Bird Family, whatever it is, the new one, the 29th of September or something.
yes, yes,
The
updated,
one I
yes.
ran was before he brought the new one in. So like the new one has those new whatever it is, the Bird extra large or something. And so
Mm-hmm,
yes,
mm-hmm.
since he added those, it takes a lot longer to run. And so yeah, like the last time I tried to run SVR and that, yeah, it timed out as well. It ran out of time. So the only one I was able
Ah,
to run the completion was before he added the new extra large.
I see, I see. Okay. How about you, Mayank? Were you able to run the combination or not?
Yeah, I haven't run the new one yet. I was on the older version, so yeah, that worked. I can be sure of that.
I see.
But
I
yeah,
see. So that's consistent with what Steve is saying. So that's probably it. I was like, man, how come it's not working for me and it's working for them? So what you're saying is it didn't work for you either. It was the prior version. But I think it's still probably good to use the prior version and SVR combo because I think that combination does better than him adding the extra large because it's yet another Deberta variant, and that doesn't seem to do a whole lot of good. So thanks for that, because I might go back and use the prior version of his notebook and run that instead.
Yeah, like that's basically what gave me the high score was SVR and his original notebook.
Yeah, yeah.
As I
I
say, when I
think that's
tried
a
the new
better
one,
comp.
yeah,
I think I'm going to do that, and then once I get that working, then I think it's time to try to do this. What I've been wanting to do, I've been saying I'll try, but just haven't gotten to it. Is this distillation thing, and which you're trying in a different way, but kind of in the same direction, right? Did you get that working on my further progress, Steve, on just getting a single model to be much better?
Well, basically, I spent the week trying to get my models to run in the new 2 GPU thing. You know, like Mayank had published the notebook last week where somebody had done it. So yeah, so like this week, I've got like the baseline one finally running with 2 GPUs, and then there's a new TensorFlow public kernel put up there. So I've got that running now with 2 GPUs as well. I was expecting to be able to get like twice as many models running for inference in half the time it would take, but it doesn't appear to be. It maybe gives like a slight advantage, but I think because of the fact that it's like sort of constantly sort of it just like spreads the batch between the 2 GPUs as opposed to running separate models in each one. And so I think because there's like sort of communication between the two, it doesn't sort of give you twice as good speed up, even though you're running on two GPUs.
So you're using the first, you said you used the PyTorch version that Zach Mueller had posted, that Mayank had posted.
Yeah, so actually can't remember his name, but this week, yeah, if you look there in the public code.
Yeah, there's CPMP. That's the person who, yeah.
That's the one, yeah. Oh yeah, this notebook at the top here, by the way, this one that's just been posted, this DeBerta family inference. Yeah, so like it is the one that you're using, Srinivas, but I think he's done weights on it, and so it gives slightly better. So this one here is the highest scoring one at the minute. So you could maybe try that with the SVR. But yeah, as Mayank says, yeah, that guy, his name, whoever it was, he's published the 2 GPU one.
CPMP, that's the guy's name.
Yep.
CPMP, let's see.
It was only published this week, so it's if you sort by, oh, there he is there. It was there. Yep. Yeah, you see FB3 / DeBerta with 2 T4.
This one?
Yeah. Yeah, so he's
and
done.
This is the TensorFlow one?
No, this is PyTorch, but it's on the 2 GPUs.
Okay. Oh, this is the Torch data parallel.
Yep.
Okay. Yeah, that's too bad that what you're saying, Steve, that it somehow the 2 GPU version, at least the simple implementation seems to it seems like it's not doing this. Oh, let me run, because we have ensembles, it would be probably better to run individual models in the individual GPUs. But what you're saying is it's doing this shared data type of approach where it's probably running portions of the batch or batches in different and combining batches of a single run or something like that.
Yeah, like ideally what I wanted to do was run separate models, one on each GPU.
Right.
But I couldn't find a way how to do that. It took me long enough to get the thing running. And you
said besides this one, there's also a TensorFlow one that you're running?
Well, yeah, like if you go back again to the code, if you sort that list by best score, yeah, you see the fourth one down.
This one?
Yeah, so that one there, it's got sort of the highest score, and it's only a single model, but it's in TensorFlow. So this one here is not 2 GPUs, but I eventually got it working on 2 GPUs. Although TensorFlow is a bit rubbish in that when you say you want to use 2 GPUs, it automatically allocates all of the GPU memory to itself. It sort of takes it all, and like when the notebook finishes, it doesn't release it. So I've had to spend a lot of time. I've eventually got it so as it finally releases the GPU memory. Because yeah, as soon as I ran this one, then it stopped me running any others in my ensemble. But I finally got it working. So at the minute I've got an ensemble of just this one, and yeah, like just the base one from that guy before. So I've got the two of them both on the 2 GPU thing. And yeah, so I actually just submitted it there this morning, and it gave me the best score I've had so far. But it didn't push me up very far, but it improved on my score, and like that's only with 2 notebooks in there. So, and plus as well, it went
pretty good. So the 2 being this one, and which other one?
The one that Mayank just said, that whatever his name is, CPMP.
I think the new one, the new one with weights.
No, the 2 GPU one on PyTorch. Just
the 2 GPU PyTorch one. Okay. The CPMP one.
Yeah, that's right. Yeah.
But that one also but that one you run as PyTorch, or you run it?
Yeah, no, it's PyTorch, but so I use the ensemble notebook that I showed you last week. You know, like where it does.
So it runs in its own environment, so you don't have to care. As long as you said the trick though is you figured a way in TensorFlow to wipe the memory, much like that guy does for in the ensemble notebook.
Sort of, yeah. The only way I could get it to wipe it was by sort of running it in its own process. But so it was a bit tricky to get it running, but it had to run its own process so that when the process terminates, it frees the GPU memory.
Oh man, interesting.
But yeah, so I've got the 2 of them running now, and it seems to go reasonably quick. I think it's going quicker than it was when it was just on a single GPU. So hopefully it means I can squeeze more models in there.
Interesting. Yeah, then we should, once you get it, I think you'll probably share what you did to get the combination working, or TensorFlow to release, because that might be an interesting thing to learn.
Yeah, there's maybe like an easier way. Like there are TensorFlow commands that say sort of clear memory and things, but they don't appear to, because it's, yeah, to get it to run on 2 GPUs, I have to use this TensorFlow distributed thing, and like it's a thing that automatically allocates all the GPU memory up front. So I didn't find an easy way of getting back to clear the memory.
Yeah, the TensorFlow APIs does that. It allocates at the beginning of the run when you give the command to, so yeah, that's one of its drawbacks.
Yeah, it'd be good if they introduced a clear memory when done. Yeah, so it's very annoying.
Yeah, that's very strange, given the Google guys are the ones who run it on clusters and who have this incredible appetite for huge, gigantic models. So one would think they would have that thing figured out to work in TensorFlow. Maybe it's just that they haven't publicized it, and there are more people on PyTorch who are, publishing how to do it easily than the TensorFlow guys. Because I'm surprised that the TensorFlow thing makes it harder when they are the guys who are out there, pushing the largest models ever.
I suppose it's.
I remember there. I suppose there is a config parameter to increase the memory to allocate the memory as per the models become available. So there is some sort of a config parameter there, which we can assign at the start of the training. Not at the start, just initially when we have that, when we write import TensorFlow as TF. So in the next line, there is some config parameters there. So we can do that. I think I remember I was once running a notebook by the hands-on ML guys, and that was in TensorFlow, and that required allocation in an increasing form of your model allocation to the memory. So I had used that there. I just remembered it right now. Maybe I will find it and post it in a Slack or something.
Yeah, and
that'd be
I've
great.
seen that before, sorry, but yeah, you can do, yes,
Yeah.
well, as I say, like when TensorFlow starts by default, it takes all of your GPU memory, but as you say, you can set it so as it only allocates it as it needs it, but it doesn't free it again. And if you're just in a TensorFlow world where all you're running is TensorFlow, then that's fine, because if you run one TensorFlow model and then another TensorFlow model, it's allocated all the memory and then TensorFlow can use all the memory. My problem is because of the fact that I want to run a TensorFlow model and then a PyTorch model, and TensorFlow's stolen all the memory by then. And yeah, you can set a limit to it. So I could say to it, you can only have half of the memory, but even so, then that means that the TensorFlow thing will run at half the speed, and the PyTorch thing that comes along afterwards, it'll only have half the memory. But yeah, as I say, if you run it in a separate process, use like the multi-process thing and run it in its own process, then when the process terminates, it does clean up. But you have to sort of include all of the code in the notebook. You can't do the thing about just loading the IPy.nb file in. So.
Oh, I see. So you're back to the way I was doing it.
Exactly.
Rather
Yes.
than the way.
Yeah. So maybe you had it right after all.
By the way, a thought, just another thought, although I don't know that you want to try it for this competition, but just as you were saying, that you were mixing because the problem is TensorFlow, then Flush, then PyTorch, because it's the TensorFlow and the PyTorch model. A thought occurred to me. As I said, you probably don't want to do it in this instance, but in the distillation chapter of the NLP with Transformers book, he actually translates the model, the PyTorch model, into and Mayank may remember it. I don't remember it translates it into what, an OVX or some other intermediate format, if you recall, Mayank, and that in fact, interestingly, it for whatever reason shrunk the model somewhat and gave about the same or better latency. And I forget what the format that he converted it to. So it may be another approach would be to convert both these models to that format and then run it. But I don't know with Kaggle and all that kind of stuff. That's why I was saying I don't know that it would be very useful in this instance. But the precise reason that he said they were approaching it was because it's a neutral format that you can kind of go to from PyTorch or TensorFlow. Do you recall off the top of your head the format that they were talking about, Mayank, in that chapter?
Onyx, ONNX. That's the format. Yeah.
Right.
That's the yeah.
ONNX, and it seemed, at least that seemed to imply you could take both PyTorch and TensorFlow to that format, right?
Yes.
Yeah.
Yeah, but I don't know what it would take to run ONNX on Kaggle. So.
Yeah, like I briefly read that chapter, but it looked as if it was going to take me down a path that would take a long time to go down.
No, I think that is probably right, because who knows what other quirks you will discover as you go down that route.
it's been
But
part of
just
the philosophy.
something that occurred to me because we were talking about, commonality between two different kind of environments.
Yeah.
Interesting. Yeah. In fact, I think look at the number of teams, right? I mean, that's the interesting part. But you're probably still on silver because as the number increases, I think the proportion ought to remain the same, right? So they still have, so the top 10%, I think, is bronze. So if you are in the top 192, then you're probably okay.
Yeah.
Or the top 200 pretty soon.
Has
And
that
you still have nearly a month. So I think a lot of people are kind of jumping on it now.
Yeah.
That's interesting.
Yeah, so as I say, this one here that at the top, it would probably be worth taking that. And then, yeah, so he's taken the standard DeBerta family thing, but tuned it a bit, I think. So if you were to take that and add the SVR to that, and
right, that's what I'll try next because I think
just drop anyone that takes
I'll
a
try
long time.
this, or else I'll also try what you suggested. I mean, this would be my first, and then also try going back to the old one and combining it with SVR because I think you still get a better result. I'm not, in fact, here's another piece of data that I wanted to share, which, for what it is worth. No, not this one. Not this one either. Yeah, this one. So here, one thing I thought was very interesting for me, number of things that kept throwing exceptions. But here's the interesting piece of data I wanted to share that makes the point that, the difference between this one is just the 928 updated one.
Yeah.
And this one, interestingly enough, is the 928 one with the 3 extra large removed for other reasons, right? Because I was seeing some, I remember the error I shared with you folks a couple of weeks back. So because I was getting that error that the, sequence length or something related was longer or shorter or whatever,
yep.
I removed those 3 extra large. And you can see that it still gives me the second best score, even with those 3 removed, compared to, and this one is an ensemble of this 3, the extra large ones removed, along with all the others, but not SVR yet. And that still gives me, a lower score than just using these 2. So again, the point of this being that those 3 extra large ones do seem to help because obviously this score is better than the next one. So having the 3 extra large ones gives a slight boost. We don't know how much, but it is definitely a better score. But adding, everything else except XVR still does not. So it seems to me that SVR is the only one that you combine with the family to get, because the family already has pretty much anything that you combine with, because, for example, this one, I removed the SVR and all other notebooks that are high scoring, I combined, but it's still lower than just the family ones. You see what I'm saying? So it seems like SVR is the only combination with the family that actually helps you boost the score compared to any other notebook.
Yeah. I think
so
like a lot
one,
of, yeah, a lot of the other notebooks are similar to the family one, aren't they? Because like the one I was originally doing was the very first one, which I think the family one just copied. So I think I was getting some
Yes.
replication, whereas the SVR one is obviously a completely different method, and I think just sort of through diversity or whatever, it's good.
Yes, absolutely. And this just confirmed that for me, because I included, except for the fifth one. The fifth one seems to be still better, but I have to debug why I can't combine it with the other model to create, the Lex somebody or the other. That guy was using fifth. And that also, when he uses Swift, then causes the notebook to take a long time. So that's another challenge with that notebook. But that's not the reason it's failing. It's failing for some other reason when I try to ensemble, and I have to debug that. But barring that exception, you're absolutely right, Steve, that, it's only this Deberta family thing pretty much covers everything. If you see any other notebook using Deberta, you can safely ignore it compared to if you already have the family in your ensemble.
Yep.
So that's what this tells me. So I'm going to remove all that and just try and, to your point, either go back to his original one, because I don't know what the difference is, but it's still the second best compared to so what I'm trying to say is my 928 updated up is probably equivalent to his older notebook, because from what you said, Stevie, the difference between these two seems to be that he included extra large, and I removed the extra large in this one myself, formatted it out basically. So I'll just go there and combine the SVR, or I'll use the latest thing that you pointed to, Steve, and combine with the SVR, and that ought to get me a little bit better than where I'm stuck at right now.
Yeah, it might be worth you starting with the SVR and then just gradually start including the models from the family one. Maybe
that might
in
be
reverse order or whatever until you run out of time.
Yeah, that might be an interesting approach too.
Yeah, so like the newer ones he's added, the big ones, the Berta extra large and stuff, they give better scores, don't they, I think?
Yes, they slightly, right? I mean, from what is now, I cannot tell. Well, actually, in his notebook itself, he has the scores, right? So
it does, yeah.
It should be possible to see. I forget where.
Are you playing how many Kaggle tabs can you have?
Oh yeah.
I
just close in.
I think somewhere in there he had. Oh no, not this one.
Yeah,
I was going to say the Deberta family one. He has the table from each one.
Yeah, I don't. Oh, this one doesn't have it. Okay.
Yeah, I think it's Deberta family has the table. You need to get one more Kaggle notebook.
Yeah. Well, the gold medal is far away for me, but I think you already have 2 silvers, don't you, Steve?
No, just one. One silver, one bronze.
But your second one, hopefully this competition will do it. Then you'll be what, competition master?
I don't know, but yeah. So if you just look on code, there again a second. And yeah, if you look at the first one there, the Deberta family inference, I think he had the table.
Yeah, I think.
Yeah, there.
Yeah, right. Yeah.
Yeah, so like that table there, that's taken. You can see it's September the 28th. So that's from the Deberta family of the 28th. Yeah, so you can see all the original ones. They only got 0.44 on the public leaderboard, whereas his new V3 large, they all get 0.43. But
yeah, but see, this is not what is actually causing the problems when I run, or at least the ones I excluded, which still seem to matter, were these 3. The V2 extra large ones.
All right.
Because these three ran okay, the large V3 large, but the V2 extra large,
Yeah.
right, were the ones that were sending me that error. But what is funny is when you run it in its own environment, then I don't see that error.
All right.
How could that be? I mean, that's weird.
Don't know, but
Because the error seemed to be with the model and its, size and the sequence size, which doesn't change depending on what environment I run in. So I don't know, something weird going on there.
and you didn't, when you cut those ones out, you didn't try that with SVR, did you know? Because if you cut those 3 extra large ones out, the V2 extra larges, yeah, your family score will drop slightly, but it might give you like enough time to run the SVR. And you can see there, so those ones there, they don't have very good CVs compared to the others. Maybe.
Yeah.
So the ones that got
did I
CV,
do that combination of V2 removing that and having? I did. I think I'll double check, but it still gave me the error. It didn't time out. It gave the exception error. So something else was wrong when I tried to combine. But then, the other comment I would have is I wasn't only combining it with SVR, I was combining it with other notebooks. And as I just told you, one of the other notebooks might have been a problem. So in essence, my attempt at combining the other notebooks is kind of futile because, as you just mentioned, the Deberta base itself includes pretty much everything you would need out of Deberta. The only one that I might want to think about is the Swift with Deberta, but that's the one that's giving problems, so I have to debug that. But anything else with Deberta is not worth trying to ensemble with it. Only SVR is worth trying to ensemble with this.
Yeah.
But actually, I think your process of, that you were going down is, I think, much more valuable, actually, which is you were trying to do 2 things, right? In the SVR, you were trying to include the fine-tuned models. So are you still doing that in your ensembles now?
Yes. So, well, I haven't put SVR back in yet, but in my previous high scoring one, yeah, so it was this sort of Deberta family, but yeah, the old Deberta family, and it was SVR, but it was the SVR which took the hidden states from fine-tuned folds. So like in Chris Diott's original notebook, he just used untrained BERT models, where so like I was using ones that were from the BERT models, the Deberta models that were trained on this competition. And so that made my SVR better.
Yeah. The one other question, because the time is of essence, that I was thinking of is, how it downloads the weights for the SVR thing, and that takes a while.
Yeah.
Is there any other way to speed that up?
Well, yeah. So in the original SVR notebook, he did the weight extraction and the training of the SVR and the inference all within one notebook. So there's 2 ways to fix that. So you can make the inference notebook where you train the SVR model externally. And then the other way is to do it where you take the hidden states and you write them into like NumPy arrays in the training one, but you don't actually train the SVR. And then you train the SVR itself in the inference bit. And like it has advantages in that otherwise the SVR models, they take a lot of space up. And so you run out of space if you start doing it with like big long hidden state arrays. And so, yeah, if you save the NumPy arrays and then train them in an inference SVR, then that works better. So like Chris Diot, he, as well as having his notebook, there's a discussion about it, and in there it sort of, he mentions it all.
I see. I looked at like that. Okay. And the other thing you were doing, and have you incorporated that with this multi-GPU approach as well that you're doing, is you were trying to use this layer-wise learning rate, right? Tweaking them per layer.
Yeah. So like I ran the original Deberta baseline model, and like when I ran it, it gives like reasonable scores, but you get like 0.44. But like something like the cohesion column has a high score on it. It's not very good at predicting cohesion. And so I took the model and explicitly made one that just did cohesion, but it does, yeah, like layer-wise learning rates, and it does that weight reinitialization. And with that, yeah, like I was able to drop the cohesion score quite a lot. And that the other notebook I showed you there before, the Keras one, that's what it does. It's using like those techniques to get the good score. But it's obviously it's doing it in TensorFlow. But there's another good notebook I saw this week. If you go back to the code again, the public code. Yeah, so here, if you sort those by date, so like it was put on this week. I'm not sure, is it recently? I don't know, is it recently created or maybe? Yeah, it's actually, if you just like scroll down the list, it's actually not for this competition, but it's some French thing. Or it's maybe not French. If you maybe sort it again by hotness, sorry. Yeah, there's a notebook there, and it's from some other competition, but it basically has all of the techniques in it. It was only put in the other day. Yeah, that one there. Sorry, the Team Bella solution. Yeah, so this one here is for a completely different competition, but it's effectively using exactly the same code as what we have. Yeah, like it's identical to the baseline stuff, apart from it's just using the different competition thing. But you can see here it's got like the techniques. It's got like a lot of techniques in it, such as the AWP and stuff. So I thought it had like a lot of good ideas. I'm not sure. And you can see he's got like SVM
I think,
as well.
In fact, I often think that, there was similarly another notebook that I have bookmarked that talks about all the different things you can do with transformers to like A, speed them up, and B, use less memory. So I think those kind of things are very, very valuable. I think Kaggle ought to kind of combine those into like a, best known methods section or something.
Yeah.
Because that would be really cool to have, that you can go and check independent. I mean, they may refer to competition, but it's kind of cool because you can, the data set exists, the methods are there. So it's kind of very practical, hands-on, that you can practice these techniques.
But yeah, this notebook here, although it's for a different competition, I thought it had like a few good ideas in it. As you can see, he does SVM, but he gets the hidden states in a slightly different way. And yeah, like he's got the AWP on it as well. I don't think he does like the layer-wise weight stuff, and I don't think he does the reinitialization, but I've seen them in other notebooks. And yeah, like they definitely help things
like if
for
you
me.
Combine all these things, it will be really kind of cool.
Yeah.
And that's what you're trying, which is really cool too. So you should maybe publish your notebook once you get something done. make it public because I think that's really good work. Oh, they have like you say, he has AWP as well. Huh?
Yeah, so I haven't added AWP to mine, but I was going to steal it out of here and stick it in and see what happens.
The other place conducive to, I mean, Swift is just Tiberta implementation of AWP, right? So let me see among these gazillion tabs I have whether I can quickly find the one that I am looking for. I'm usually good at it, but now that I say it, I'll probably be suck at it. I wanted to show you the. I don't know, it's really slow. You know, the one of the things I ensembled is this one rapid lightning. This one. This one has AWP implemented with Tiberta, Steve. So you can even try, because this is the one, the inference version of this is the one that I have included, but I'm having trouble because of it saying, but you see this Swift?
Yeah.
Yeah. And he takes it from the Tiberta repo. And it works. It just lengthens the runtime though significantly.
Right.
Just so you're aware.
Is that only in training?
Believe yes, because remember adversarial weight perturbation is just for making the model robust.
Yeah.
So not in inference. Now that I say that, then it shouldn't, well, yeah, the training is where it gets longer. I don't think the inference, and this is the inference notebook. But the score is just 0.44. And this is the one that I included, and I have to debug what's happening with it and as to why it's giving me some error. I don't know, maybe just had internet turned on by default in the notebook, and he uses 4-fold instead of 5-fold. I mean, you can kind of increase that and stuff. But these are the two. This is the implementation of Swift AWP, but with Tiberta.
Right.
And he has just also taken it directly from the Tiberta implementation. If you want something working for the current problem. This guy, Lex Tumburo. Any more luck, Mayank? Have you tried anything different?
No, I'm along the same lines. I've also been experimenting with the couple of GPUs. So the notebooks that use those GPUs. Yeah.
Do you think it made much difference? Did it speed things up much for you?
I think so. There's a 60%. I mean, 60% there is faster from the original, from the P1 100s. If it's I didn't notice the exact number of seconds, but yeah, it is faster.
So when you say 60%, are you measuring with time or something, or just a guess?
That's just a nominal guess, but yeah, if we use time, then yeah, we will get the exact number of seconds.
Yeah, because 60% is pretty significant because, I used to do the Intel MP thing, and when we went, in fact, you get, if you're getting 60%, when you go from 1 to 2, that's pretty significant improvement. From what Steve was telling me, although he wasn't quoting precise numbers, but it didn't seem to be that big. I doubt whether it will be 60% if it is doing this shared kind of approach rather than running each model on a different GPU. Because the other issue is, GPUs in general, have less memory than CPUs, and they're not built to swap. And I don't know whether the P100s or whatever the setup. Oh, this might be another interesting question. Do you know whether the setup is something that uses the NVIDIA communication channels themselves called NVLink, or it's just using the traditional PCI Express? I mean, we're getting into the hardware weeds, but that makes a big difference because without it, the ability of the two GPUs to communicate is the bottleneck because it's very slow PCI Express bandwidth compared to memory bandwidth or compared to anything else. I don't recall the numbers off the top of my head, but the NVLink boosts it very, very significantly. And that's why NVIDIA came up with NVLink, because going across the PCI Express is a huge bottleneck.
Part of my problem as well is I'm just running it for inference. I just wanted to try and speed inference up. And like obviously within the sample test file, there's only 3 rows in there. And so, yeah, it's when you're sort of saving the sample inference thing, it's only running three rows on 2 GPUs. And so it probably takes more time setting up than it does running it. And so I think it's faster when I actually do the submission on the proper stuff.
Oh, yeah, for sure. Yeah. The boost you would probably get is, you're right. Yeah, no doubt. The 3 is, in fact, that's frustrating too, because the 3, in fact, the difference between 3 and what they run is, I think once you include SVR and in fact, once you include Debutta base, like you said, it takes 6 hours to run just Debutta base family on the entire inference data set. Whereas, it finishes in like, I don't know, 20 minutes or so on the 3 samples, but it takes 6 hours for the 6 or more than that, I think, for the entire data set.
Yeah. And,
oh, by the way, which raises this question, Steve and Mike. Right now, the hours that we are running is for the private data set. And I haven't looked at what percentage of the data they have released in private. But if is the public. If the private data set is 60%, let's say, and the private is just 40%, then you have to account for the difference in the data set size when we account for the runtime, right? So your runtime has to be, it cannot be at the edge or else it will just topple over. You see what I'm saying?
No, they don't. When you submit it here, they mark both. They mark the private and the public. They just don't give you the score. So it is running on all of the test data. So it'll not, the time won't increase. So you're okay. So if it runs okay now, that means it'll be okay. yeah, I don't think they run it again. I think it's like already been scored on the hidden private data.
I okay, got it. That's good to know, because I was like, whoa, otherwise we have to account for that data
Yeah,
chain. But you're right. I think I recall, except for those kind of problems where there is, the 3-month data or something. For these, they run it, but they don't leave it. Yeah, I recall that. You're right. Yeah, I forgot about that. Yeah, you're right.
yeah. So like in this competition, as soon as the competition finishes, the results should pop up. They don't need to
Yeah,
run it again.
yeah, you're right. I forgot about that. Yeah.
So, according to CPMP, who's the Kaggle, he has calculated the time, and the code runs in 7,700 seconds versus the 12,000 seconds of dual versus single P100s, dual T4s versus single P100s. So approximately it's according to him, it's 37%, 36% faster. The dual.
Yeah,
Yeah.
that's probably makes sense, because 60 would make me go wow, because they've really optimized something. 37 is something that I think I would probably seems
Yeah.
more reasonable. Yeah.
Yeah, that
As
there's as well. That's training, isn't it? Though.
yeah, that's training.
Yeah, so I don't think you get as much on inference.
Yeah. Because in training you have implemented, I think so, they use the PyTorch's data parallel. So data parallelism is being used here. So yeah, that will give approximately, because the T4 is less powerful as compared to P100s. So if we had the same type of GPU, single P100s versus dual P100s, then we would have got approximately in 50% range. But since this is a T4, so yeah, the 36, 37, 38%, it's which is less than the 40% mark. It's the accurate, I think so, result
Yeah.
here.
Yeah. And thinking about it, as you were talking, Mike, again, I'm guessing, but one of the reasons that TensorFlow guys may not have been optimizing it for running it on GPUs in parallel all that much is because for their in-house, they probably do TPUs, not GPUs when they run those massive things. And that TPUs, again, per T, as in tensor processing unit, they are much faster, and they are also optimized to communicate with each other better.
Mm-hmm. But
So,
but there is also the GPUs too. Kaggle has those APIs. I am forgetting the class name of that particular API, but it is there. Maybe I will post it. I will find it and post it in the Slack. And there might be some people who have tried this multi GPU T4 things, and they may have posted a kernel there.
where are you talking about?
In the general competition part, not in the
Oh,
specific competition, but in the general competition part, maybe some of the guys may have posted it. I will find it and post it in the Slack then.
okay, cool.
Okay.
All right, a lot of stuff to attempt and even to stay afloat and not get sunk by all the new entrants.
Yeah. Yeah, I'm
It's
trying
like
to go
swim
upwards
really
instead of
fast
downwards.
so you can stay in place.
Exactly. Yeah.
Yeah. Mhm.
Okay, thanks for joining, folks. See you all next week.
Cheers. See you next week.
Bye.
Uh,
Bye.
bye, guys. Take care.